Christmas present under the tree. It's for me! Yo, it's what I've always wanted. Fire-resistant ceramic fiber insulation. Alright, so I got this cool insulation stuff. It's like super heat resistant, insulative, and super cool, wow. But I need to cut it to shape. I need a fire brick. I don't know where I can find one. Oh, I know. There we go. This thing can handle the temperature of melting steel. Alright, this fire brick, well, I need two. And it's a bit thick, and so I'm thinking I can cut it into two. Now, if I use a normal saw like this guy, it'll dull the freaking crap out of it. And so, I'm just going to get this random piece of metal and cut a little bit of notches. What a wonderful sound. And that'll probably be able to cut it, because this thing is really flaky. So, it should... Well, after lots of sawing and lots of powdery ceramic stuff, which needs this little mask here, very handy, I finally got these cut in two. I don't think it fits. I can fix this. Alright, let's see if this works. Oh yeah, fits in there real good. Perfect. Nope. Nope. Yeah. Alright, first thing I'm probably gonna mount is maybe this piece of aluminum and I don't know, this thing. I don't really need it. Pretty sure it's aluminum too. Chop it up and put it in there. My hair is gone.
What will I ever do? I've lost my identity.
When I do my crazy rocket projects, I always end up with a bunch of random metal parts that I'm not going to use. So, I could save a lot of money if I can melt that metal and cast it into the shape that I want, and then I can just reuse the metal that I don't need. And I can do that with a very fancy furnace called a Foundry. It's not very fancy, but it does the job. So, I guess I shall explain how a Foundry works. Is this entertaining? Do you watch this? What? Does anybody watch this? Why do I make videos? Why are we still... I bought this thing off Amazon. You can just kind of put metal in there, heat it up, cast it, and then machine it on the lathe. Well, that would be great, but I need a lot of heat to melt it down. So, I'm going to use some propane. Now, propane gets really hot, so... There's an issue. When I direct the heat of the torch onto the crucible, it just kind of radiates out into this air, and a lot of it doesn't go into the metal. So, need to fix that. One way to fix that is by containing it so that the heat doesn't escape. Probably make it out of steel. But then there's an issue with making it out of steel. The steel will heat up, and then when it heats up, it radiates the heat. So, if we just line the inside with some insulative fire resistant stuff like bricks and TKOW fire bricks, things of that sort of nature, then should be golden. Okay, so there's gotta be something to keep in mind with this. You gotta have an input and an output. You gotta put and I put some thought into it. So my design with the inputs focus. So my design with the inputs and outputs are pretty conventional. As you have two inputs of super hot gases. They flow around the crucible, and then they flow out of the top here. From a top-down view, they're at an angle so that they kind of do a little swirl around and evenly heat up the crucible to make it real nice and cool looking and hot. Or hot looking and cool. I don't know. But there's another issue. You see this little guy? It's a bit small. Not gonna produce enough heat. We need more spice. So we need to make our own torch and use a lot larger of the tank. So we gotta figure out how this thing works. The torch, how it works is you have pressurized propane here, and you have a valve that when you open it, shoots out propane into this tube with a tiny little hole right there. So it has a little stream of propane. Now the inputs of air are basically just holes in the tube. Now a cool thing happens when you have a moving fluid next to just an open air non-moving fluid. The Venturi effect happens, and the moving propane actually sucks the air in with the propane. And so now you have mixed propane and air going through this little tube here. They're kind of mixing because of the turbulent air kind of wiggling around. And once they've fully mixed, they combust right around here, and they are ignited around here with this little button here. So, with my design, I just have a flexible tube with pressurized propane going through this little pea-style machine on my lathe, shooting propane through. And it would be inside of a tube that is just held on with two little bolts. And the ambient air will be sucked in with the propane. And then it will mix along here and set on fire in the foundry. And hopefully, the fast-moving flow of the propane will keep the fire in the foundry and not in the tube. So, now the diameter of the tube is 1 inch and a quarter. They were just random tubes that I found laying around, and well, the tubes I'm using is galvanized, which isn't the greatest because the galvanized surface can burn off and release toxic fumes, but I'm gonna cool off the tubes with water and do it outside so that the fumes hopefully won't murder me. Here I am in some fantastic weather. I'm gonna test these little tubes here. Turn on the tank. Well, I don't know. Looks pretty cool. You can see, yeah, it's looking like the propane and air is mixing pretty well. Yeah, I don't know how hot that is. Maybe I'll just go ahead and put it in the foundry and see if it works. I'll mess around till it works and tell you how. Wait, yep. See something scary? Gotta try and light that thing with the lid on. So I struggled to get the foundry working for a little while, so instead of showing you all the footage of the confusedness and the struggle, I shall explain the stuff. First, I discovered something about the big boy propane tank. So here's the big boy tank with the valve pretty much opened all the way, and with my valve put on there. And here's the inputs to the foundry, and well, I think there might be like a flow limiter or something. Is here. Listen to it. Once I open it, you can hear it. I open it, gets intense, and then I just continually open it, and it stopped. It's now at its lower flow. Future me here kind of interjecting. You see that little circular brass piece in the O-ring there? I think that might be the flow limiter. and when it's pressed in, it lets out more flow. And with the fitting that I have, it doesn't push it in all the way. I tried to modify it so that it would push it in all the way, but when I threaded it on there, it wouldn't be able to thread on all the way, and it leaked a lot. So I bought this little piece, which threads onto the inside with a left-handed thread, and it pushes it in, and it lets out more flow. I might drill out that little center hole there to let even more flow, because it's a little restriction point, but I don't know. Anyway, back to your normal video. Here's a demonstration. It's at the maximum it is right now. When I open it further, it suddenly decreases. And this is an issue because in the Foundry, let's say the Foundry is here, I need the pressure of the propane to be high enough that it keeps the flame in the Foundry and not in the tubes. Yep, we're losing a lot of heat through these tubes out here. That heat needs to be in there, not in the tubes. Frickin'. And so, it took me a while to figure that out, but when I did, it worked! Yay! But later, when I put the crucible in there, it suddenly stopped working. Not even when I took the crucible back out. Like, what the crap? It just doesn't like me. Why must you do this to me, Foundry? Okay, so for some reason now, it's starting to set on fire outside of the Foundry, not inside of the Foundry. It's not in the tubes, that's fine. But like, what? See that fire there? Seems like it's escaping out of the bottom. And, oh shoot. It seems like it's escaping out of the bottom and the input there. I drilled some holes into the inputs to see if some more air gets sucked in and that mixes inside of the Foundry and burns. I eventually figured out that these little outputs on the top were too small. When it's too small, the input of propane in combustion makes it pressurized in there. And the pressure makes it so that the flowing of the propane kind of stops and the flow doesn't work as good. Meaning there's unburnt propane and there's pressure in here. And when there's pressure, it leaks out propane from the edges and sets on fire. And the burning of the propane is also coming out on the top rather than being inside. So I made the outputs bigger and now it works. So, yep, I don't know why it worked at first and then it stopped working and then I fixed it via this method. It should have not worked and then not worked and then fixed, but you know, the world be that way. So you can see I got some aluminum in there. As I poke around in it, you see the slag on top coming off. Actually, I think it's just straight up ready to cast now. It'd be funny if I set my pants on fire. Now is the real test. My aim. Holy frick! I set my cast on fire!
It looks like an aluminum sombrero. Can I poke it?
If you're not afraid of hot.
I'm pretty sure you're doing like what 80% of people want to do, including myself a little bit. It's like one of those things where you're like, hey, I want to do that, but what would I actually do? I don't know. But you actually have like an excuse, you know?
The excuse of being a nerd.
Stop. Actually, hey, I'm not a nerd. Being a special type of nerd. Your mom's a nerd. Yo, look at that. Oh. Snap.
Yeah.
Look at that.
It's so clean.
What are your thoughts about this cylinder?
It's a lot smoother than I expected. I thought sand was gonna kind of pour in from the sides and make it uneven, but I'm glad that it's very even, because it's going to be a lot easier to machine on the lathe now. I guess now the true question is the inside completely solid? I'll find out. I think I might experiment more with the inputs and the output and the sizes to see if I can optimize this so that I don't waste any propane, and then I'll start getting to machining my own nozzles for rockets and doing all sorts of cool stuff.
Why does it work?
What work?
My marriage. No, alright, I have to do another question that would be entertaining to someone else.
Retain the audience?
Yeah. What else? What was the hardest part about this entire experiment?
Hardest part? Probably achieving the balance between the input and the output with the propane, getting it to mix properly. But physically most challenging, probably cutting the holes in the pot, because I had to cut like 20 holes to make a big hole. The reason cutting the holes was so difficult was that what I was cutting through was ceramic coated steel, and the only things that I had to cut through that were small little cobalt drill bits. So I just had to cut a bunch of holes in a circular shape. Alright, well, this is kind of the end of the video. I think I'm probably gonna do some tests with the Foundry to try and upgrade it and have it melt steel, potentially. That would be pretty cool. But, yeah, this is the end. Get out of here. Leave. Go away. Now. Do it before it's too late. No!